Welcome to our demonstration showcasing data encryption at rest using the REGDATA JDBC driver. In the realm of banking, safeguarding customers' data is paramount. Access to this sensitive information should only be granted through authorized applications. The primary objective of this proof of concept is to unveil a seamlessly integrated solution for selectively encrypting data within any Temenos application that stores data via JDBC driver. Temenos stands to gain numerous advantages from this initiative, including the capacity to oversee model bank definitions of personally identifiable information fields, conducting all data processing activities within the secure confines of the Temenos infrastructure, and markedly bolstering our overall security posture. For banks, the benefits are equally compelling. Notably, an additional layer of security is established for PII and other sensitive data subject to regulatory scrutiny. Furthermore, achieving compliance with data protection standards becomes more streamlined, facilitating easier auditability and reporting. Illustrated in the accompanying diagram is the architectural framework employed for this endeavor. Safeguarding sensitive data necessitates rendering it into an unintelligible format. While this demonstration utilizes Transact Explorer as the client interfacing with Transact, it's important to note that any application accessing or storing data via JDBC driver can be accommodated. Transact Explorer is not shown in the diagram. At the heart of our solution lies the JDBC driver, a critical software component facilitating the interaction between Java applications running on the server and the underlying database through the JDBC API. In this POC, we leverage the JDBC driver provided by REGDATA. When the driver receives data, such as the customer name John Smith, it undergoes encryption before being securely stored within the database. Upon retrieval, the encrypted text is transmitted back to the JDBC driver, which then decrypts the data. Finally, the data is presented in plain text within Transact Explorer, ensuring a seamless and secure user experience. Use cases: securely storing sensitive data in the database with encryption, retrieving sensitive data from the database as plain text, ensuring successful close of business operations. Performance considerations: encryption and decryption processes should not significantly impact transaction performance, including arrangement activity and close of business operations. Now we will demonstrate encrypting current customer data effortlessly with the REGDATA bulk encryption script. Encrypt and decrypt customer data from Transact Explorer seamlessly, without necessitating any alterations to the Transact Explorer. Presenting performance test findings for financial transactions and COB operations. Displayed on the top left is the Chrome browser, which has two tabs. The first tab is the Transact Explorer, and the second tab is the REGDATA platform. In the bottom left window, we have an open terminal where we will execute the REGDATA bulk encryption script to protect customer data. On the right, we have the PG admin tool, utilized for PostgreSQL database management tasks by administrators. I'm transitioning to the PG admin tool window. Upon examination within this tool, it's evident that the database currently holds customer data without encryption for customer 100,100 among others, and the database administrator can access this data in plain text. We need to protect this data. To safeguard existing data in the database, we must utilize the REGDATA platform. I am now transitioning to the REGDATA platform in Chrome. We have configured the tables and fields we want to protect. This is explained in detail later in the setup section. I am now transitioning to the terminal window. Here, I will execute the REGDATA bulk encryption script. We need to pass the database URL along with its credentials and the JSON file containing the list of exclusive table names we want to protect. REGDATA has mentioned that in future versions, the need for passing the JSON file will be removed with automation. The encryption job has started and takes a few minutes to complete. We can monitor its progress in the terminal. The encryption job is now complete. Now transitioning to the PG admin tool. The existing customer data is now protected. Upon running a query to view the details of customer 100,100, it's evident that field number 2, representing the short name of the customer, and field 6, the address field, among others, have been encrypted. Only a user with the privilege to access customer data can view this in the Transact Explorer. This concludes the use case for encrypting current customer data effortlessly with the REGDATA platform and bulk encryption script. However, it's worth noting that it does not protect the new customer data or modification of existing data through Transact Explorer, and the sensitive data will end up in plain text in the database. This can be resolved by leveraging the Postgres driver from REGDATA. Now, I will demonstrate this using the Transact Explorer. I am now transitioning to the Transact Explorer window. First, we will create a new customer entry in Transact Explorer. I am inputting a command in a command line to create a new customer. The form for capturing customer data is displayed on the screen. Upon creating a new entry for customer Tony Kraft, his current address is recorded. To safeguard his privacy, the name and address fields containing personal data will be encrypted and securely stored in the database. Regardless of which UI you utilize, the encryption task is executed within Transact using the PostgreSQL driver from REGDATA. I have submitted the form to create a new customer. The new customer has been created. I'm transitioning to the pgadmin tool to view the details of the new customer in the database. The information in the database is encrypted, ensuring data security. We notice that fields like short name, field 2, street, field 5, and other fields containing customer name and address information are encrypted. I will now query the customer by name in Transact Explorer by running the command in a command line. I would like to search for the customer named Tony, whom I just created. When viewing the record, the encrypted data seamlessly transforms back into plain text, providing clear visibility to the user. Furthermore, data in other registered applications like standing.order is also encrypted. Now, I will modify the existing customer data for customer Harry Crisp by entering the input command on the command line for customer ID 100100. The input form is displayed on the screen. I am updating the short name, which corresponds to field number 2, and committing the record. Now, I am transitioning to the pgadmin tool where I will execute a query to view the details of Harry Crisp. It's notable that field 2 remains protected, and we can seamlessly view the details back in Transact Explorer when reviewing the record. This wraps up the scenarios for securely storing and retrieving customer data use case. Performance. Initially, performance baselines were established using the native PostgreSQL driver. Subsequently, the performance of the REGDATA JDBC driver was evaluated against the native driver. Each test was conducted on a separate instance of databases copied from the master database. The databases utilized in the performance tests each comprised 200,000 customers and 213,000 accounts within BNK branch. Additionally, within branch UK1, 20,000 customers, along with a commensurate number of accounts and funds transfer records, were utilized for COB operations. The JMeter tool was used to conduct performance tests twice, initially using the native PostgreSQL driver and subsequently with the REGDATA JDBC driver. Similarly, Temenos Monitor was utilized for comparing COB performance. Since the only distinction between two performance runs lies in JDBC driver, this approach yields consistently acceptable results. The table displays performance results from a test run. Notably, due to encryption and decryption, and additional latency is evident in the diff column. Similarly, the COB elapsed time with the REGDATA JDBC driver was comparable to the elapsed time with the native PostgreSQL driver. For further details, please refer to the Confluence page associated with the proof of concept. Displayed on the left is the Chrome browser, which has 3 tabs. The first tab is the Transact Explorer, used for exploring Transact. The second tab is the REGDATA platform, where we register tables for encryption, and the final tab is the JBoss Management Console, where we will show the deployment of a new Postgres driver from REGDATA. On the right, we have a terminal window connected to the EC2 VM via SSH. we will be demonstrating the deployment of a new driver using this terminal window. I am now transitioning to the Transact Explorer window. I am now logging in as the input user. I will now run the inquiry to query the application cz.cdp.data.definition. This pivotal application encompasses a comprehensive inventory of all applications, tables, and fields potentially harboring personally identifiable information, along with their intended purposes. For the purpose of this proof of concept, we have elected to focus on tables from 5 applications: aa.arr.account, account, customer, funds.transfer, and standing.order. These 5 application tables should be registered in the REGDATA platform. I'm now switching to the REGDATA platform. The displayed page is the REGDATA platform. In the Instances tab, a class is defined for each table we want to protect, with reusable categories defined within each class. Currently, the mapping between aliases and actual table field names is done in a JSON file in the JDBC driver. The Transformations tab defines the transformations for each category of fields. For example, to search encrypted data by name, OPE string short tokenization encryption is applied. The Rights Context tab allows us to define transformation, read or undefined rights. For example, the database user, the admin, has transformation rights, allowing to read encrypted data in plain text and transform it back. Users with read rights can see the encrypted data as it is, while users with undefined rights cannot see any values for encrypted fields. Only transformation rights were tested in this POC. The Processing Contexts tab contains the mapping between aliases and their transformations. I am now transitioning to the terminal window connected to the EC2 virtual machine running Transact application. The system functions by substituting the standard PostgreSQL JDBC driver with one supplied by REGDATA. In the JBoss application server environment, we seamlessly deploy REGDATA's JDBC driver along with its dependencies. I am now transitioning to the JBoss Management Console to demonstrate the additional configuration. The driver is prominently listed among the JDBC drivers. Notably, the Transact data source T24DS is configured to utilize this driver. Also, the database connection is successful as shown in the notification. In this demonstration, we illustrated the process of configuring the latest REGDATA driver and registering application tables within the REGDATA platform for encryption, followed by executing a job to safeguard existing data. Additionally, we demonstrated the protection of newly entered customer records in the database and conducted a comparative analysis of performance results. Thanks for watching.